Hi Paul, I just wanted to record a quick video so you could see the state of the FPGA simulator. The first thing to know is this bit up here is all you need to write to invoke my C code, and the student would type, their code in here like this. So the example thing I have here is you have 7 LEDs, 7 buttons, technically switches. You'll see in a second why I said switches. And here, the rightmost button, or button 0, is, the rightmost LED is always equal to button 0. But for the rest of them, an LED is equal to the XOR of the LED to its right and the button underneath it. So if I run my simulator here, so if I hit, here these digits under here are to remind you which key you hit on the keyboard. So if I hit 1, this leftmost LED is equal to 1, the value of the buttons, XOR 0, the value of the LED to its right. So you can see I can switch it like that. But now if I hit 2, well, this LED here is equal to 1 XOR 1, which is equal to 0, and 2 is equal to 1 XOR 0, which is equal to 1. I think you get the point. And of course, if I hit 8, I can toggle all of them because it carries through the negation. Now I'm just hitting buttons at random. So you'll notice that there's a time scaling. There elapse 500 nanoseconds in simulation per real-time second. That's what this time here is showing. This value is actually in picoseconds. I should fix that. But the reason why I bothered to go to the trouble of doing that time scaling is, let's say that the student, wanted to have a 100 megahertz clock. So I can sort of simulate that here, for example, by saying LED 0 just toggles every 5 nanoseconds. Well, normally on a real FPGA this would be way too fast to see, but the nice thing is I can change the timescale here to be, let's make it 10 simulation nanoseconds per real-time second. So now we'll see that last LED flipping twice a second. And that's a nice thing that you can do. At some point I will try to make this timescale like a runtime parameter, or maybe even like a generic parameter on this fake FPGA. Oh yeah, you do have to instantiate the fake FPGA module, but that's not a big deal. But there you go, that's it. So this slows down the time scale. You'll notice that it's a little bit laggier on listening to my key presses, but that's to be expected when you slow it down so far. But again, we can speed it up to be a heck of a lot faster here. And by the way, you press Q to end the simulation. So now it's flipping super duper fast, and well, it's kind of too fast to see. Kind of like what would happen in real life. So I'm pretty pleased with it. I'll send you a link, and that's all I have to say.